Hello students, so our last lecture we discussed the three types of strain: longitudinal strain, volume strain, shear strain, shearing strain, three types of stress, Young modulus. Okay, Young modulus means longitudinal stress by longitudinal strain. So now see one theory type question students, and answer be yaad rakhjo. See what is the question. Length of wire is L1 when tension in wire is T1. Okay, length of wire is L1 when tension in wire is T1. Then next, length of wire L2 if tension is T2. Okay, when length of wire is L1, what is the tension? T1. When length of wire is L2, what is the tension? T2. We want to find original length of wire. Okay, so students, it is under theory based question. Remember the answer is, so options are L1 plus L2 by 2. What is the first option? L1 plus L2 by 2. Second option, L1 T2 minus L2 T1 upon T2 minus T1. L1 T2 plus L2 T1 Okay students, so see what is the question? When length is L1, when length is L1, what is the tension? T1. And when length is L2, what is the tension? T2. Okay, chalo. So now how to find, see students, here we use the formula of Young modulus because here length is changed. Okay, so we use the formula of what? Young modulus. And what is the formula for Young modulus? F by A upon delta L by L, F by A upon delta L by L. So what is the Young modulus then? FL upon A delta L. Young modulus means what? Longitudinal stress by longitudinal strain. Longitudinal stress is F by A and longitudinal strain is delta L by L. Now take delta L as a subject. So if we take delta L as a subject, then what is the answer? FL upon AY. Then what is the answer? FL upon AY. Now delta L means change in length. L is original length. So see what is the first, now length becomes what? L1 from L. Okay, what is the original length? L. But when tension is T1, length becomes L1. So what is the change in length? L1 minus L. What is the change in length? And what is the tension force? Same we write what? Same we write what? What is the change in length? Now length becomes L2. So what is the change in length? L2 minus L. L is original length. What is the tension force now? T2. Chalo. So now this is equation 1. This is equation 1 and 2. We want to find original length here. So students now divide both the equation. Equation 1 is divided by equation 2. So L1 minus L upon L2 minus L. L upon AY cancel. So T1 upon T2. Chalo. Now cross multiplication. So L1 T2 minus LT2 L2 T1 minus LT1. Now from this L is common, so we write L1 T2 minus L2 T1 LT2 minus LT1. So L1 T2 minus LT1. So L1 T2 minus L2 T1 upon T2 minus T1. Chalo. So what is the original length of wire? L1 T2 minus L2 T1 upon T2 minus T1. Chalo. L1 T2 minus L2 T1 upon T2 minus T1. Chalo, so this is the what? Original length of wire L1 T2 minus L2 T1 upon T2 minus T. So remember this answer, students, in the terms of theory. Okay, so remember this answer. Chalo, now next we discuss, students, bulk modulus. Next we discuss what? Bulk modulus. Now students, bulk modulus means what? Bulk modulus is a ratio of volume stress to volume strain. So bulk modulus is a ratio of volume stress and volume strain. Okay, bulk modulus is a what? Ratio of volume stress and volume strain. So volume stress means what? As we know, volume stress means what? Pressure. Okay, volume stress means what? Pressure. And volume strain means what? Delta V by V. Volume stress means what? Delta V by V. And students, here we place negative sign. Here we place negative sign. Why we place negative sign? Because when pressure increase, volume decrease. Okay, pressure and volume both are inversely proportional. So here we place negative sign. So bulk modulus is equals to minus P upon delta V by V. So we can also write in this way, students, minus PV upon delta V. We can also write in this way, minus PV upon delta V. Okay, P means pressure, V means volume, and delta V means what? Change in volume. Sure. And what is the again unit? Unit of B is what? Same as the unit of pressure. And what is the unit of pressure? Newton per meter square or Pascal. Chalo, clear students, the bulk modulus means volume stress by volume strain, that we learn in a wave chapter also students, okay. Speed of sound wave in a gas is what? Under root B by rho. Chalo, say that we discuss in a wave also students. Now 1 upon B, reciprocal of B is known as K, means compressibility. Okay, reciprocal of B is known as compressibility. And what is the unit? Unit of compressibility is what? It is a reciprocal of B, unit of K. What is the unit of bulk modulus? Pascal. So what is the unit of compressibility? K, Pascal inverse. Okay, student. So bulk modulus means volume stress by volume strain. Now students, we discuss its numerical that asked in a previous year exam. First question, see that question asked in a 2017. What is the question? The bulk modulus of a spherical object. For spherical object, what is the bulk modulus? B. Now what is the given? If it is subjected to a uniform pressure P, the fractional decrease in a radius, okay, due to uniform pressure P, due to uniform pressure P, fractional decrease in radius, fractional decrease in radius of sphere. Chalo. For spherical object, bulk modulus is B, due to uniform pressure P, fractional decrease in a radius of sphere. Means we want to find delta R by R. And what are the options, students? B upon 3P. Option B, 3P upon B. P upon 3B. Or P upon 3. For spherical object, bulk modulus B, due to uniform pressure P, fractional decrease in a radius of sphere. So we want to find delta R by R. Chalo. So how to find, students, delta R by R? How to find? See students, first here in the answer we write the answer in terms, see in the option, most of the option in ABC, answer is in the terms of bulk modulus, okay. Answer is in the terms of what? Bulk modulus. Fractional decrease means what? Fractional error means means change by original, okay. And ama into 100 કરી દો, delta R by R into 100, then it becomes percentage error, okay. Chalo. So see in the most of the option bulk modulus is given. So we start the our solution from the bulk modulus minus P delta V by V. So we use this formula. We want to write answer in the terms of P and B. So we can write that delta V by V is equal to minus P by B. So now find delta V by V. Okay, students. Now we want to find delta V by V. Chalo. Away, it is a spherical object. So what is its volume? 4 by 3 pi r cube. Now use the concept of error. So 4 by 3 pi is constant, so we cannot consider in a error. So delta V by V, what is the power? R cube, power is 3. So 3 delta R by R. So students, in the place of delta V by V, in the place of delta V by V, we write what? 3 delta R by R. So what is delta R by R? Means fractional change in radius P upon 3B, and minus indicate what? Fractional decrease. So what is our answer? P upon 3B. Okay, that is the word fractional decrease in a radius. That is what? Fractional decrease in radius. So now next question, and minus indicate decrease. Okay, so it is a fractional error, delta R by R. So now next question. Now next question asked in 2015. The depth of an ocean is 2700 meter. Approximation depth. What is the depth of ocean? 2700 meter. The compressibility of a water is for water. What is the compressibility? 45.4 into 10 raised to minus 11 Pascal inverse. And density of water, what is the density of water? 1000 kilogram per meter cube. Find fractional compression in water. At bottom, find fractional compression in water. And the options are 1.2 into 10 raised to minus 2, 1.4 into 10 raised to minus 2, option D, 1 into 10 raised to minus 2. The depth of a ocean is what? The depth of an ocean is what? 2700 meter. Means what is H? Depth is what? 2700 meter. Compressibility K is given, density rho is given. We want to find fractional compression, means we want to find delta V by V. Why students volume is why students that water at bottom is compressed? Due to the pressure of water. Okay, due to the pressure of water column, that water at the bottom is compressed. બહુ ઓછો ફેર હોય students. The options are -2 ના ટર્મમાં, but there is a negligible compression, but we want to find. Okay, So due to that water column, okay, due to the water column, water at bottom of ocean is compressed, and we want to find that fractional compression in water. It means we want to find delta V by V. So students, see here again we start from the formula of bulk modulus, because see, compressibility is given, and compressibility is what? Reciprocal of bulk modulus. Okay, so what is the formula of bulk modulus? P delta V by V. We want to find delta V by V. Take delta V by V as a subject, that is a fractional compression, fractional error. So delta V by V is equals to P by P, and 1 by P, 1 by B is known as compressibility. Okay, 1 by B is known as compressibility. Chalo, so now compressibility is given, but pressure is not given. So what is the pressure due to fluid column? આપણે next chapter માં જોશું સ્ટુડન્ટ્સ, તમને યાદ આવી છે. Pressure due to fluid column is what? H rho g. આમ તો આમાં આપણે એટમોસ્ફિયરિક પ્રેશર એ કન્સિડર કરતા હોય, P is equal to PA plus H rho g. But students, here depth is very high, 2700 meter depth. So we can neglect the atmospheric pressure. Okay, suppose if depth is not too large, suppose તમે થોડાક જ ડેપ્થમાં હોય, then we can consider both the pressure, atmospheric pressure as well as pressure due to fluid column. Okay, suppose if this is the ocean, તો આપણે અહીંયા જ હોય, if we plan, then we consider both the pressure, atmospheric pressure and pressure due to fluid column, H rho g. But now here we find at the bottom. Now we find at the bottom, so we consider only H rho g. Okay, atmospheric pressure is 9. If depth is not large, then we consider both the pressure, atmospheric plus pressure due to fluid column, that is H rho g. Then we write P is equal to PA plus H rho g if depth is not large. Chalo, so but here depth is very large, 2700 meters, so we consider only H rho g. Chalo, now place all the volume. What is the depth? 2700, so 27 into 10 raised to 2, density 10 raised to 3, G10, compressibility 45.4. So we can multiply only 27 and 45, students. Okay, 0.4 neglect. So multiply only 27 and 45. So 27 into 45, so you get 1215. 1215. 2 plus 3 5, 5 plus 1 6, 6 minus 11, minus 5, shift the 3 point. So what is the answer? 1.2 into 10 raised to minus 2. It is also, this is known as fractional decrease in a volume, fractional error, or it is also known as volume strain, delta V by V. So it is also known as volume strain. Chalo, okay students, so this is the examples of related to bulk modulus, and both we discussed 2 questions of bulk modulus, and both the questions asked in an exam. Chalo, now we discuss shear modulus. Chalo, now we discuss students shear modulus. So shear modulus G is what? It is shearing strength It is what? It is a ratio of shearing stress by shearing strength. Okay, as we know, in the case of shearing stress and shearing strain, tangential force is there, and in that case shape of the body is changed. So F by A upon delta x by h. F by A upon what? Delta x by h. So we can also write in that way, Fh upon A delta x. Fh upon A delta x. Okay, Fh upon A delta x. So again, unit is same, students. Delta x and h, meter cancel. It is also in meter. Delta x means displacement, meter, height is also in meter, so it is cancel. No unit of strain. Okay, and force by area means Newton per meter square. So again, unit of G is what? Unit of G means unit of shear modulus is Newton per meter square or Pascal. And students, remember that thing, value of shear modulus is 1/3 of Young modulus. Okay, shear modulus is what? Y by 3. Okay, shear modulus is what? 1/3 of Young modulus. Chalo, now next, students, so the, G is shear modulus, and shear modulus is what? 1/3 of Young modulus. Chalo, now students, we discuss some important points. Chalo. So what is the first point? Value of all the modulus means Young modulus, bulk modulus and shear modulus does not depend on stress and strain. It depends on material. Okay, for different material, G means shear modulus, bulk modulus P and Young modulus Y are different. So first point, does not depend on stress and strain. Okay, does not depend on what? Stress and strain. It depends on what? It depends on material. Now students, Young modulus Y and shear modulus G defined only for solids. Young modulus Y and shear modulus G are defined for solid only, not for liquid and gas. Why, students? Because see, in Young modulus length is changed, but as we know, length of liquid and length of gas is not changed. In shear modulus shape is changed, but for gas and liquid shape is not changed. So Young and shear modulus are defined for solids only, and bulk modulus is defined for all solid, liquid and gas. Bulk modulus is defined for all the three, for solids, liquid and gas. For solid, bulk modulus is high, then for liquid and for gas it is very low. Okay, for solid value of bulk modulus is high. And students, for rigid body value of Young modulus and shear modulus is infinite. Okay, because what is the reason, that we will also discuss, but first see for rigid body. Is what? Infinite. Why? Because students, see, both the Young modulus and shear modulus is what? Stress by strain. But see students, for rigid body, shape or length means there is no change in a dimension of a rigid body. What is the definition of rigid body? In rigid body, distance between atom remain invariant. Distance is not changed. So in rigid body, length is not changed, shape is not changed. So strain is 0, because strain means delta L by L, delta X by H. But strain is 0, so for rigid body, Y and G is what? Infinite, because strain is 0. Chalo. So this is the notes, important notes, and we discuss the shear modulus. Chalo. Now students, we discuss elastic potential energy. There are the two formula for elastic potential energy, but first we discuss what is the elastic potential energy. See students, when wire is stretched, then work is done, and this work is stored in the form of energy of wire. Okay, when elastic wire is stretched, then work is done, and this work is stored in the form of elastic potential energy of wire. When elastic wire is stretched, then work is done. This work is stored in the form of elastic potential energy of wire. This work is stored in the form of elastic potential energy of wire. Chalo. So what is the formula? What is the formula for elastic potential energy of wire? So that is U half. What is the first formula, student? Elastic potential energy U is equals to, first formula is very easy to remember, half stress into strain into volume. Okay, half into stress into strain into volume. So you can also remember like that, sigma into epsilon into volume. So half, what is the formula of elastic potential energy? Half sigma into epsilon into volume. Chalo. Now we want to write, because in most of the question students Young modulus is given, so we want to write this formula in terms of Young modulus. Okay, now we want to, so this is the easy formula, half into stress into strain into volume, that is the what? Elastic potential energy. Now we want to write students in terms of Young modulus. So how to write in terms of Young modulus? See, what is the meaning by Young modulus now? Young modulus means stress by strain, means Young modulus means sigma by epsilon. So in the place of sigma we write Young modulus into strain, okay, in terms of stress. See, what is stress? Stress is equals to Young modulus into strain. Strain means epsilon, so stress means Young modulus into strain. This is the what? Y into strain. Then this strain is as it is, and volume. Now simplify. Now see here, 2 strain, and what is the strain? Delta L by L into delta L by L, because 2 strain. And what is volume? Area into L. 1 LL cancel. So what is the formula? Half YA by L delta L into L. So delta L square. Delta L means change in length. So two formula for elastic potential energy. First formula, half into stress into strain into volume. Second formula is in the terms of Young modulus, half YA by L into delta L square. So now next students we discuss energy density. So now we define what, student? Now we define energy density. So now energy density means what, students? Energy per unit volume. Energy density means what? Energy per unit volume. This is the elastic energy density, students. Before we discuss energy density of wave, energy density of electric field, energy density of magnetic field, energy density of EM waves. So many topics related to energy density. Now this is the elastic energy density. So what is the energy density? Energy density means energy per unit volume. Okay, energy density is nothing but it is what? Energy per unit volume. Chalo, so energy density means energy per unit volume. And what is the formula for energy? Half stress means sigma into strain epsilon into volume and divide by volume. So volume cancel. So what is the formula for energy density? Half stress into strain. Okay, so what is the formula of energy density? Half stress into strain. And what is the formula of energy? Half stress into strain into volume. Chalo, now next students next we discuss one numerical. Chalo, for wire what is the Young modulus? 2 into 10 raised to 11 Pascal. For wire, what is the Young modulus? 2 into 10 raised to 9. If the elongation strain is 1%, elongation strain means delta L by L. For strain for change in length is 1%. Then energy stored in the wire per unit volume. Then energy stored in the wire per unit volume in joule per meter cube. And Young modulus is 2 into 10 raised to 10. So what is the option? 10 raised to 6, 10 raised to 8, 2 into 10 raised to 6, option D, 2 into 10 raised to 8. So elongation strain means what? Delta L by L is 1%, so 1 by 100. Okay, now we want to find energy stored in the wire per unit volume. So energy per unit volume means we want to find energy density rho. And what is the formula for energy density? Half into stress into strain. Stress means sigma, strain means epsilon. But see students, strain is given means delta L by L is given. Okay, but stress is not given. That stress is not given, but Young modulus is given. So what is the formula? Young modulus means stress upon strain. So stress is equal to, so stress sigma is equal to Young modulus into strain. Chalo, so here we write what? Half into Young modulus into strain. Now what is Young modulus? 2 into 10 raised to 10. What is strain? 10 raised to minus 2. So what is the answer? 10 raised to 6 joule per meter cube. Why joule per meter cube? Because energy density means energy per unit volume. That's why we write joule per meter cube. Chalo, now next question. The area of cross section for railway track. What is the area? 0.01 meter square, means 10 raised to minus 2 meter square. And the temperature variation is 10 degrees Celsius. And coefficient of linear expansion means alpha, है ना? Alpha means what? Coefficient of linear expansion 10 raised to minus 5 degrees Celsius inverse. And what is the Young modulus for the railway track? 10 raised to 11. Chalo, we want to find energy stored per meter in a track. Energy stored per meter in track. Now see students, why here energy is stored? Because see students, as we know, in the case of in a railway track, due to the change in a temperature, length of railway track is increased, है ना? Here change in length is what? Change in length is due to the temperature difference. So due to that temperature variation, length of road is increased, and now due to that increase in length, energy is stored in the track. And see students, here what is the change in length? Alpha L delta T. Why we use this formula? Because here for change in length, change in the temperature is responsible. That's why we use that formula. Alpha is the coefficient of linear expansion, L is the original length, and delta T is change in length. Now we want to find energy stored per meter. So we want to find what? U means energy stored per meter. So we want to find U by L. Okay. But what is the first energy stored? It is known as elastic energy. So energy stored in track. Here we write for energy stored there are the two formula, but here see Young modulus is given. So we use that formula, pi A by L into delta L square. See, we use that formula, okay, because Young modulus is given. Chalo, now what is delta L? Alpha L delta T. Chalo, now square of all the term. So alpha square L square 1 LL cancel. So half YA alpha square into delta T square. But see students, we want to find energy stored per meter. So we want to find U by L. So U by L. Why we divide by L? Because we want to find energy stored per meter. So U by L half YA alpha square delta T square. Chalo, now what is Young modulus? 10 raised to 11. What is area? 10 raised to minus 2. What is alpha? 10 raised to minus 5, its square. And what is delta T? No need to convert unit because both are in Celsius. Chalo, 1 by 2 means 0.5. 11 minus 2, 9. Minus 10 into 2. So 9 plus 2, 11. 11 minus 10. So 10 is remaining. 11 minus 10 is 1. So 10 raised to 1 is remaining. 0.5 into 10. So 5 joule per meter. Why per meter? Because energy per unit volume.